Hi class, today we're talking about properties and I am on page 16 in your binder for lesson 5-1. So let's review our properties. The commutative property is a property where we are changing the order of the numbers when we're adding or multiplying. So the commutative property can be the commutative property of addition, or it can be the commutative property of multiplication. I remember this property by the CO that is in commutative. The CO tells me to change the order of the numbers. So if I look at number 1, I need to change around the order of the numbers. 3 plus 2 plus 1. If I change around the order, I could have 2 plus 3 plus 1. And this works out because 3 plus 2 is 5, plus 1 more gives me 6. Same thing here. 2 plus 3 is 5, plus 1 more gives me 6. So that works out. If you look at number 2, we're using multiplication. We need to use the commutative property of multiplication to rearrange the numbers. So if I rearrange these numbers, one example could be 7 times 8 times 5. You could also do it 8 times 7 times 5. 8 times 5 times 7. There's more than one way to rewrite the order of these problems. Okay? Associative property is also for addition or multiplication. And in associative, we regroup the numbers without changing the order. So the order of the numbers is going to stay, so that's a giveaway between commutative and associative. But in associative, the groupings change. And I like to put parentheses around the S's in the word associative so that the S's cue me in that there are parentheses, and that is what I'm changing. So if we look at the example, this one is an example of the associative property of addition. So if I were to do this, the order of the numbers stays the same, so I'm just going to rewrite the numbers. But the numbers that are within the groupings needs to change. So 3 plus 2 is in groupings this time. 2 plus 1 is going to be in groupings the second time. If we look at number 4, this is of multiplication, the associative property of multiplication. So the order is going to stay 5 times 8 times 7. But if we look at this one, 8 times 7 was in groupings here. I need to change the groupings so that 5 and the 8 are in the groupings. Okay? The identity property is the ID property. Think of your photo ID. Your photo ID changes a little bit, but it always is still going to have your face on it. So we are keeping the number the same, so we're performing an operation of either addition or multiplication to keep the number the same. Well, think, what can I do to keep a number the same? What can I add to a number to keep a number the same? Well, I'm going to add 0. 3 plus 0 gives me 3. That's the identity property of addition. Same thing down below. I multiply by 1 to keep the number the same. So 5 times 1 gives me 5. And I could think of some other examples. 5 plus 0 will give me 5. That would be an example of the additive identity. And 30 times 1 could be an example of the multiplicative identity. Okay, inverse. Another word for inverse is opposite. So we're looking for opposites here so that we can cancel what is going on in the problem. And this is very important whenever we're solving equations, because we always want to cancel the number that is stuck with the letter. So if we look at this one, what's the opposite of addition? Well, it's subtraction. What's the opposite of a positive number? Because this 3 is positive. A negative number. So if I have 3 and then I take 3 away, I end up with 0. And that relates back to our identity, because if we add anything to 0, we end up with the same thing, so it cancels. Same thing with number 8. Now number 8 is very similar to what we were doing in order of operations with fractions, because this is actually our keep, switch, flip property in number 8. We keep the first fraction the same, put it over 1, switch to multiply, and we flip over the fraction to do our division here. Okay, so we have multiply and we flip to divide. And when we do that, 5 times 1 is 5. 1 times 5 is 5. And 5 divided by 5 is equal to 1, which relates back to our identity property. If we had something else in this problem and we multiplied it by 1, it would have canceled and left the number the same that we were trying to get by itself. So the inverse property is whenever you do the opposite. Okay, if we look at the ones down below, the distributive property. When you distribute something, that means you're passing something out. So you're passing out to a group of people, or just to a group. Or in math, it's going to be a grouping, which is our parentheses. So if we are passing out a number to the group, if we look at number 9, the number we're going to be passing out is the 3, because it's squished outside this grouping here. And the way we do this is we always say outside times the first, outside times the second. And what that's talking about is the numbers inside the parentheses. So I'm going to do the outside number times the first. So this is a positive 3 times a positive 2. And then I'm going to do outside times the second. So positive 3, so I'm going to do plus 3, times the second, which is 1. It's a positive 1. So that's all you need to do for the distributive property. You share the 3 with the 2 numbers that are inside the groupings. Now there could be more than 2 numbers inside the groupings, but in the cases that we're going to be working with, there's only going to be 2. Same thing with number 10. Distribute the number that's on the outside of the grouping. Outside times the first, outside times the second. So it would be 5 times x, and then 5 times a positive 2, and it's a positive 5, so it's going to be plus 5 times 2. Now, you may see these written in a different way. You may see this multiplied out, so 3 times 2 would be 6 plus 3 times 1 is 3. So you may see it with this part first, and then 6 plus 3 after. Now, if you notice, the parentheses that were around the grouping here went away. That's one giveaway of distributive property, is you'll notice that parentheses will be on one side of the equation, and then they'll disappear to the other side. Same thing holds true for this one here. 5 times x we would rewrite as 5x. And then positive 5 times 2 gives you a positive 10. So we could see it as this on one side, but then 5x plus 10 on the other. The multiplicative property of 0, it says its name. We are multiplying by 0. So anytime you're multiplying by 0, it's the multiplicative property of 0. It says its name. So 3 times 0 is 0. X times 8 is going to be 8x. And then we're going to multiply that by 0. This right here multiplied by 0 equals 0. So that's the 0 property. Okay. Reflexive. If you've ever been to a doctor, they sit you on the table and they take a little hammer and they knock your knee and your leg kicks out. That is called a reflex. Your body does it instantly. Same thing as if you were to put your hand on a hot stove. You don't have to think about, I need to move my hand because it's hot. Your body automatically does it for you. So if you think back to elementary school, your teacher would say, if I were to write 3 on the board, how many little circles would I draw? And you would have said 3. 3 is equal to 3 little circles. so 3 is equal to 3. Same thing if I were to do it with 4. 4 is equal to how many x's? Well, you would put 4 x's, which is still 4. So 4 is equal to 4. So reflex is a number. It's all the things that you've learned since elementary school. So if we look at this one, 21 is going to be equal to 21. X is going to be equal to x. It just stays the same over the equal sign. And this will relate back to our check step when we do our equations. The symmetric property is also a new one. The symmetric property is the if-then property. So it's only over one equal sign, and it can only have a term on one side and a term on the other side. That's how you know it's reflexive. So if x is equal to 2, I could flip that around and I could say then 2 is equal to x. Notice that there is a number and a letter, and that's it. I don't have 2 plus x equals x plus 2, because in this case I have too many terms on either side. I have two terms. I have a 2 and an x, and I have an x and a 2. I can only have one term, the 2 and then the x. So if I look at the next one, if A is equal to B, then B is equal to A. You just turn it around. Okay? So go ahead and try the practice on the next page, on page 17.